All right. Well, thanks everybody who made it to this presentation in the middle of the day on Saturday. It's supposed to be raining outside, but it's a nice day, so most folks would rather be outside, which is good. We have a few more weeks of like weather like that. All right, so I wanted to share kind of some experience in an area that seems to be picking up broader interest, which is using more edge devices to make things around us a little bit smarter and more cognizant of what we need and how can we be helped with different things. In the earlier, even in the current implementations of those smarter things, there are some fundamental issues that we've come to discover. So I want to chat about that a little bit. On the next slide, it's taking a while to load. Okay. Well, this is a slide with all our sponsors, which obviously we're grateful to, as well as all the organizers and volunteers. I'm not sure if you see that slide on my screen. It shows it's still loading.
Yeah, we're still seeing a loading screen.
It was perfect until a minute ago. I'm not sure if some of the images are remote and taking a while to load. Should I exit present notes to see what's happening?
Yeah, let's try that.
Unable to load file. What is this about? Okay, looks like it's on now. Okay, it shows now. Everybody sees the sponsor slide?
Yep.
All right, cool. Well, sorry about that. Again, thanks for sponsoring all these folks and for organizers and volunteers making this happen in a virtual way. Last year, I remember in person was a massive event. There was, I don't know, hundreds of people were there. It was fantastic. But this is good, keeping this tradition alive. All right, so moving on, kind of to set the base, what are some of the basic metrics that modern businesses are measured on? Recurring revenue, high customer LTV, low churn, profit margins, NPS, low CAC, and usually rarely seen board meetings or kind of investor conversations as a business metric, the value of protecting customers' best interest or advocating for the users' well-being. These are more concerns for maybe PR, maybe for legal sometimes, but rarely a business metric. So kind of let's look at like a business that meets almost all of these metrics pretty well. And it's been around, but the margins are still pretty high. Customer retention is still pretty good. Low churn. The tobacco business obviously thinks about the best of users' interest with big educational signs that inform users what's best for them. The one metric that is not doing very well for this business is new customer acquisition. So over time, the regulatory issues and our customer awareness has led to pretty steady decline in new user acquisition. So over time, that business is not doing that great, but they're compensating with higher margins with existing customers. Because one of the findings that are kind of popular now is that even though these warning signs are prominent and they cause some initial reaction when users buy the product, they do very little to change the habits of existing users. So they keep using that product, very low churn. So what does these signs remind us of? They remind me of these signs, where customers are in almost addicted to some of their products, and they would use their favorite services no matter what, even if there's an extra pop-up that they need to click on. Maybe they read some of these signs, maybe they don't. They're not as interesting as the cigarette signs, so they probably have even less effects on the end users at this point. But what are some of the side effects of just having signs and probably good intentions of complying with user data privacy, but not actually doing a whole lot in substance? So these are some of the side effects, right? When hackers are able to get into the privacy of a home of a consumer and connect with a child behind the parent's back. Always not a very good thing. There is a lot of awareness. But that can be a big problem in itself. And what happens when products that collect data and analyze it, and they actually mean to do it in an ethical way, but sometimes things go wrong, and what happens when the victims are actually very well educated and trained and strong technical organizations with cybersecurity teams and all that. Even they can become the victims. So something doesn't seem quite right of showing compliance and meaning to do well, but not actually doing a whole lot to prevent user data from being collected, analyzed, and eventually open to hacks. So there are two big trends, right? One is that regulators will keep tightening things up. The EU proposed a new version of GDPR, which is it looks like it's going to be a lot harsher on what AI applications are allowed to hit the market. It's a draft now, but we'll see. Based on the EU's history, it'll probably become reality later this year. So for new products being built, we kind of have a choice whether to actually look deeper and care what can protect users and what's in their own best interest, and decide whether that is in the also in alignment with the product's profit goals, revenue goals, as we build these new products, or it's better to just do the minimum to comply with the current regulatory requirements and fly under the radar. So it may be very high of an ask to kind of not deep in the honeypot, not collect and store user data, not sell it, not even look at it in transit, and even if you want to stretch it even further, replace footprint of privacy policy with actually showing the source code, so it's easy to verify that user data is not being collected in a way that can be can expose privacy. So it's really more of a strategic questions, no easy answers, but to find out kind of in the long run what wins, we have to kind of swim upstream and test it out in the market. I think what I'd like to share now is that it looks like feasibility on the technology side is not an issue anymore, and then time will tell whether in terms of business this is also a good route to go, good direction. So I'll kind of share a case study that I've been involved with, and everybody can make their own conclusions what makes sense for them. So we've started attacking the problem of early fall detection. It's a pretty prominent issue that keeps growing as more people prefer to age in place, stay in their homes and not go to professional managed facilities, even though the problem is exposed there as well. But if some of you are not aware of kind of the high-level metrics, every second an older adult over 65 in the US is called into emergency room, and then every 90 minutes dies because of a fall. So fall is a pretty serious indicator of fatal injuries. It does have a pretty big dollar sign attached to it. Being able to respond within the first hour turns out to be a huge factor of how that fall develops, whether it's there's recovery or something serious happens. And also, interestingly, most of us are aware of the emergency pendants or smart watches that can detect the fall, but it turns out that only 8% of people actually want to wear that type of wearables. They either rather not wear them or don't. I'm not sure if they should be wearing anything. There are a number of factors why. So if we're going to attack the potential solution to this without a wearable, what could it look like? One potential option is to come up with some sort of smart camera solution that observes high-risk areas constantly, and it doesn't use a regular motion detector, which would be triggered by objects or pets. It is able to kind of intelligently detect people, and even more trigger detection when a person falls. Some other things that we may want from that is to not share data anywhere outside of the house or the home or the facility. Not share it with the cloud or anybody who does not need to see the data, and only sends notifications to family or caregivers that are authorized as needed. So the solution that we're able to put together on the technology side is really that small box. Stores all the data on device, all the AI inferences on device. Communication is direct between family or caregivers, mobile or desktop and device, client device, and that box. No data in transit or at rest is visible to any cloud services. And we even stretched it to make it open source, so it's easy to verify that it does what we say it does. On the business model, again, to the point of can this do well without storing the user data or trying to sell it in some indirect or direct ways. We're pushing forward with hardware and maintenance subscription. Looks like users are happy to get enough benefits to where they'd rather not spend time on installing, maintaining everything on their own. Integration with notification services, caregiver call centers, emergency first responders is another benefit. That is just a notification service. It does not reveal any data of what's happening in that home. And there is actually new revenue areas that we're discovering with patient management platforms. One example is in the assisted living community, apparently there is quite a bit of disconnect between families remotely caring for their elderly and caregiver companies that are visiting several times a week. Because there is little transparency in what's happening, there is this notion that families are anxious. Did somebody actually visit or not? It's hard for them to tell. So this type of integration and being able to keep people informed seems to be a point of interest. So to pull back a little bit and zoom out of what this looks like, the camera and the computing device that are in the house do pretty much all the thinking. There is only one cloud signaling server that is responsible for helping endpoints and those camera devices to find each other behind firewalls. But that signaling server is not in the route of the data at all. It only helps them find each other initially when they need to connect. And then all the data is direct through the shortest possible internet path, encrypted end-to-end with asymmetric keys. A different perspective of that is using the kind of a tech stack. It's a progressive web app on the front end with Vue.js is one of the frameworks there that can be installed on iOS and Android and desktop. Peer.js in the middle, these are all open source frameworks, which is over WebRTC. And then on the back end, the reference platform is Raspberry Pi. It can be a number of other small portable computing boards with TensorFlow Lite and WebRTC stack again. So in terms of the AI inference, what is turns out to be completely feasible and seems to work pretty well is the ability to capture video frames at about 1 second spaced out. Falls are in the 600 to 800 millisecond interval. So with 3 frames that are spaced out around seconds, it is guaranteed to catch a before and after of a fall. Then using PoseNet, it's a popular model for detecting key points on a person's body. We're able to estimate spinal vector and from there determine whether there is a movement downwards of the body position and detect the potential fall that needs to be looked at. So the key enablers that have become available in the last couple of years, which might not have, without them, this project would not have been probably possible, I think are the availability of high-powered, low-cost computing boards, Pi 4, NVIDIA Nano, Go Color, and Coral, and so on. Also, the fact that AI frameworks have continued to perform better and shrink in size. TensorFlow Lite, for example, a couple of years ago, in the 1x version was over 10x the battery. Now, in its 2x version, is 1 meg. And they're pushing it even harder towards microcontrollers. So things are looking better in terms of intelligence on device, on small compute devices. Another big enabler is the fact that WebRTC has become a official standard from Web3C end of 2000 and is now available in all major browsers. Plus, it has very active community on a number of other platforms, Go, Python, Node.js, which makes peer-to-peer communication encrypted, secure, now possible. And kind of out of the box because it's already in all browsers. And then the final big trend is that progressive web apps have also now been adopted by all major browsers on mobile and desktop, which makes it possible to do things like communicating peer-to-peer from a browser. Right? There is no need to connect to a public web server from a web app, or there's no need to even write a mobile app just so you can connect to a device in the same proximity. That's a pretty big change in the last couple of years. Another trend is that for some time, the push has been towards bigger models with billions of parameters and bigger data with millions, hundreds of thousands, millions of examples processed to train new custom AI models. But Andrew is one of the prominent researchers in the area that most ML folks know well of, and he's been pushing for some time the discovery that with just a few hundred examples of high quality data, you can get the same results on a much smaller model, ML model, than on a lot more expensive big data model in the cloud. So that's pretty important when it comes to IoT applications. And then the final trend that is I want to mention, it started in 16, 17 timeframe with Google popularizing the way that they train the Android keyboards to get better prediction. It's federated learning. They started off, but the research papers that the community picked up is growing really fast. And the bottom line is it enables training custom AI models at scale while preserving user privacy, and multiple or a big number of devices can share knowledge without sharing data. There are a number, over 10 now, open source frameworks that are out there, and they're pushing forward with production implementations. I think that's been a pretty big trend, pretty important too. So that's, I think, most of what I wanted to share on this topic. Again, thanks for the sponsor, thanks for volunteers. And if there are any questions, I'm happy to answer here. And then after that, I'll hang out in this Slack channel. Any questions for anybody?
Thank you, Ivelin. We had a couple of, or at least one question come up during the presentation in the chat. Woody had a question related to one of the earlier suggestions. You had a slide that was suggesting ways to improve the security. I think it was the security slide. And one of the points you had was showing the source code. But there is certainly going to be a concern if we're worried about hacking, wouldn't showing the source code be increasing the likelihood of hacking? I think I captured Woody's question there.
Yeah, it makes sense. I think this is a tough question. It's more of a strategy and philosophy. In my experience, the argument of open source code being less secure has proven to be mostly less of an issue than proprietary code, because what has happened historically from, first of all, every proprietary network framework or product uses a ton of open source already. And what has happened historically is when an issue occurs with an open source framework, usually the world knows about it and jumps on it and gets it solved pretty fast. There are endless number of examples, as opposed to proprietary, where in most cases, the intention is probably to react in the proper way and fix it fast. But we also know a number of examples where companies prefer either not to tell about it or to not be able to fix it correctly because they don't have good and complete control of all the code. Like the SolarWinds example is probably one of the biggest one in the recent history, where it was an indirect hack that affected security of hundreds of thousands of businesses, from Microsoft to pick whoever using SolarWinds. And because it's a proprietary stack all the way through, it took forever to, at least 6 months, to be even detected and then backtracked and where exactly things went wrong, with so much of the code not being transparent to people in the food chain. So again, I don't think it's an easy answer, but kind of I lean on the philosophy of open source doesn't hurt.
Thank you. We had a question come in through the Slack channel from Sarah Reneker. A lot of us may be working with different levels of AI, and not everybody's going to be well versed in AI or machine learning. Do you have any recommendations for kind of beginner level AI, machine learning kinds of resources?
I think there is by now a lot of great resources. The one that I like personally a lot, which seems to be appropriate for folks that are in research and engineering and products, are the Coursera courses by Deep Learning AI. They do touch on fundamentals. They touch a lot on various types of production applications, and how to pick teams, how to pick data, just cover a lot of different basic aspects that bring you kind of up to speed on the most important things, and then from there you can decide what you want to specialize in based on your role and your goals.
Yeah, I'd throw in the.
I'll make a note to share it in the Slack channel after we close here.
I was just going to say, there are quite a few things in LinkedIn Learning on AI and ML as well. And if you're interested in specific hardware like the NVIDIA Nano, there's a whole set of courses that are associated with that.
Yeah, I agree. It's pretty much, it's not that important where you start. Just start somewhere. There's a lot of good resources, and then they all cover similar fundamentals. And then you can develop based on your interest and needs which direction you want to dive into deeper. But I'll share this Coursera course in a minute in the Slack channel.
Got time for a couple more questions, maybe? All right, I think we'll wrap it up. It is just about 1 o'clock, and we will start our 15-minute break before the next session. I'd like to thank Ivelin for his presentation.